And from the time we met, obviously we got along in some way, but there also were times where we seemed to be saying things that made no sense to the other. And as we have continued along, and as Gordon has gotten more interested in education, we have begun to understand each other better and better. And one of the ways that we understand each other better, I think, is that we say that fallacy is an interesting word, but it doesn't necessarily mean so much, because things can be true in different ways. And we can also know things in different ways. And so, for example, people would often say, "What does your husband do?" I'd say, "He's a physicist." They'd say, "Oh, he must be very smart." And I'd say, "Well, yeah." On the other hand, I'm pretty smart too. But when you do medieval literature, it doesn't seem as if you're as smart as when you do physics, if what you understand is that there is one kind of question you ask, or one type of answer that you look for. In science and math, you talk about looking for elegance, right? The best theories are the elegant theories. So what does an elegant theory do? It says very concisely something which makes profound, deep, deep sense. And the difference between a scientist and somebody in literature, as myself, is that we ask different kinds of questions. And both of us look for elegance. But what we understand as elegance is a little bit different. So Gordon, when you're looking for elegance, what's the kind of question you look at?
Well, our research, for example, is really a set of open-ended questions about, how the universe works, or the nature of the physical universe.
And the question that literature asks, and that philosophy asks, is what are those essential understandings about human nature?
And then in science, we use causal reasoning. Things follow, one, two, three, and it's very important that the result be reproducible. Otherwise, it's not very useful. And the solution has to be validated by some theoretical proof, usually, hopefully, and or by other experiments that validate the ideas that came from your own experiment.
And if you're in literature, particularly when you were, as I was in medieval literature, cause and effect is not a particularly important relationship. Instead, you use analogy, you use inference, you use metaphor, which is actually analogy. And the result is unique. A great work of art is, in a very important sense, irreproducible. Its truth or its validity resonates with human experience. So something written as long ago as Gilgamesh, which is one of our earliest texts, rings true for us. And when Enkidu weeps for his friend, we who read it today weep too. The imitations lose the elegance of the original solution. So it's not that we don't look for elegance, we look for a different kind. And you have Einstein.
Yeah. So in physics, Einstein's idea that time depends on our relative speed was completely contrary to the standard theory of Newton at the time. And so we don't feel that that's necessarily the end point, it's the progress. And as is Euclid set up a simple set of propositions of geometry, and we were hoping that these were complete, but we find now that they're not complete. It's a progression.
And that is sort of this elegance. Both Einstein and Euclid meet the criteria for elegance in science. Milton, we use Milton, you'll see a little bit later why we chose Milton as the poet that we're talking about. But when Milton was writing Paradise Lost, he chose to do a great deal of imagery around the sun. And he saw the sun as the kind of image that he could make resonate in many different directions. And so that's why he chose it. And he saw that by using this one metaphor and playing off of it, and playing off also on the pun between sun, S-U-N, and S-O-N, which is, of course, Son of God and all of that stuff, he could do things that no other imagery would be as powerful. And so that he could, without saying too much, he could say a great deal very concisely, in the same way that Euclid's 5 theorems can say a great deal concisely.
Even though he was aware of the Copernican universes.
So I've been working on this very much. I work now. I wouldn't say I've given up medieval literature, but my basic concern is very early childhood, particularly 3 to 8-year-olds, which is where everything is set. What happens to the 3 to 8-year-old determines who the adult learner becomes. And I am currently working on a book about the importance of doing quality intellectual work from the child's very first school experience to, we're arguing today, to their ultimate school experience. So from pre-K through PhD, through research, if you are doing reasonable, worthwhile work, you should be doing quality intellectual work. And what is quality intellectual work? Quality intellectual work means that you are a lifelong learner. It also means that you're a lifelong player. And all of these are different angles on the central issue, which is, if you are a learner, if you're a player, if you're a researcher, then you are involved in inquiry. And so inquiry is kind of at the center of quality intellectual work, and I think we can go on to that.
Do an example, please.
So inquiry calls for deep engagement with the question. It has to be something that, first of all, is an open-ended question. That was at the top of both Gordon and my column, right? It has to be an open-ended question. If it isn't a problem, then you can't do any problem solving. So you have to have something which is a problem when you begin. Misconceptions and errors. Deciding, should we call this a fallacy? Should we call this a paradox? Or should we say, if we shift it around, what looks like a fallacy has a different kind of truth to it? That, the misconceptions, the dissonance, is where most of our learning and most of our progress comes from. And so that if what we understand is that inquiry, that learning, that progress in science and in literature, that elegance is all a result of inquiry, then we are kind of in the same place.
A quick example, I mean, you probably don't remember when you learned to walk. That was probably one of your first physics experiments. Or when you first learned to stand up. And I bet you failed. But you learned how to stand up eventually. I think you're all sitting down now, but I'm sure you can all stand up. And that was a guided inquiry. You were testing gravity, right? You didn't go off and read a book about Newton's equations. You did the experiment again and again until you succeeded, and you didn't give up. So there's a very good example of one of your first guided inquiry experiments. So I think we have Mary, you just explained this slide.